Hello everyone, welcome to C Programming and Data Structures. In this presentation, we will consider part 3 of program 1 stack ARR0 as the top, making the first element of the array as the topmost element of the stack. So without any further delay, let's get started. In this presentation, we will write three different functions: isEmpty, isFull, and peek. These are the three most important functions we have to write. In the previous presentations, we have learned how to write the push function and the pop function. Now, this is the right time to discuss these functions. How to write isEmpty function, isFull function, and peek function. So without any further delay, let's move on. Let's just try to understand how to write isEmpty function. This time we don't have the top variable, isn't that so? Instead of the top variable, we have first variable, which keeps track of the first inserted element. You can see the current status of the stack. Currently there are 3 elements in this stack and the topmost element of the stack is 3, right? We already know this, that the first element of the array is the topmost element of the stack, right? And you can see the status here. The first variable is holding this value 2, which means that the first inserted element is at index 2, right? You can see the index 2 over here, and this is the first element, right? We are keeping track of the first element instead of the topmost element. There is no need to keep track of the topmost element because the position of the topmost element is fixed. Now, we have to write isEmpty function for this stack. We have to check whether the stack is empty or not. For this purpose, we have to understand how the first variable changes with time, right? First variable keeps track of the first inserted element and not the last inserted element onto stack. Isn't that so? Let's try to delete the elements one by one and note the status of the first variable. This is our job. We have to note the status of the first variable after deleting all the elements of the stack. Let's just try to understand what will be the value of first variable after deleting all the values of this stack. Okay. Here we have this particular array, which is the representation of the stack. That's why I have named it stack ARR. And we have a first variable which keeps track of the first inserted element. You can see the position of the first variable changes with time. That's why we have to keep track of the first inserted element. Currently, this value indicates that the first variable is at index 2. Now let's just call the pop function for the purpose of deleting the topmost element of the stack. We know that this is the topmost element. We have to delete this element, right? For this purpose, we have to call the pop function. And what does pop function do? It simply deletes this element, right? It actually deletes this element by shifting all the elements towards left. First, it shifts this element towards left, so this becomes 2. And then it shifts this element towards left, so this becomes 1. In this way, the topmost element gets deleted. After this, the value of the first variable will get decremented by 1. Isn't that so? This is what pop function does. It simply decrements the value of the first variable by 1. Now this is an important step. You can see the status of this first variable. Currently this variable is holding value 1, which means that the first inserted element is now at index 1. Previously it was at index 2. Now it is in index 1. Fine. Now let's call pop function once again because we have to delete this element now. Now in order to delete this element, of course, this element will get shifted towards left. And then of course, this value will get decremented by 1. Now the first inserted element is at index 0. The first inserted element is at index 0. This means there is just one element in the stack. Please remember that we are having an illusion here. Currently you can see there are 3 elements in the stack, but first variable is giving us this illusion that there is just one element in the stack. You can see the first variable is holding this value 0, which means that the first inserted element is at index 0. Right? And this simply means there is just one element in the stack. This is an illusion. After this, let's call the pop function once again. Now this is the final call to pop function because we have to delete this element. Now deleting this element simply means that we just have to decrement this value by 1. So this becomes minus 1. Now minus 1 indicates that the stack is now empty, although it is not. This is an illusion. Therefore, this value simply indicates that the stack is empty. Okay. So first variable behaves like a top variable only. Isn't that so? It is no different than a top variable. If first is equal to minus 1, then it indicates that the stack is empty. If first is equal to -1, then stack is empty or stack underflow. Fine. This is how our isEmpty function looks like. We just have to write this. If first is equal to -1, return 1, else return 0. Instead of top, we have first. That's it. Very simple, right? Now, after writing isEmpty function, it's time to write isFull function. Let us assume this is the current state of the stack. And you can see that the first inserted element is at index 3. Therefore, the first variable must hold this value 3. And here the topmost element is 3, right? First variable keeps track of the first inserted element and not the last inserted element onto stack. The same problem. First variable keeps track of the first inserted element and not the last inserted element. Let's try to add the elements one by one and note the status of the first variable. Here we are about to write isFull function. For this we have to make our stack full. And for this purpose we have to consider an example which will make the stack full. And then we will also note the status of the first variable. We will note what value is there inside first variable after making the stack full. First we will push this element 30. This push function will simply push this element at this particular position. But before pushing this element, this push function simply shift all the elements towards right. So here, first this element will get shifted towards right. Here 46 will get stored after shifting. Then this value will get shifted towards right. So this becomes 1. Then this value gets shifted towards right. This becomes 2. And finally this value will get shifted towards right. So this becomes 3. Now we can place 30 over here, right? In this way we have successfully inserted this element. Now, apart from this first variable will get updated. Isn't that so? This value will get replaced by 4 because this is the new status of the first inserted element. Our first inserted element is now at index 4. Isn't that so? Now again we will call the push function. This time we will try to insert this element 90. For this purpose again this element must be shifted towards right. Then this element must be shifted towards right. Then this element. Then this element. And finally this element, right? Now we can add this element over here. So this value will get replaced by 90. Okay? You can see the stack is full. And obviously the first variable has to be updated because you can see the first inserted element is at index 5. What does it mean? Value of first is 5. This simply means that if first is equal to max minus 1, we know that max indicates the maximum size of the stack ARR. You can see the maximum size of the stack ARR is 6. This array is capable of holding 6 elements. So max must be 6. If first is equal to max minus 1, then we can say that the stack is full, right? So again, the first variable is behaving like a top variable only. If first is equal to max minus 1, then stack is full or stack overflow. This is how isFull function looks like. Here we just have to check this condition. If first is equal to max minus 1, then return 1, else return 0. Okay? This function is not different from the usual stack ARR function, right? Here, instead of top, we have first. That's it. Now we will see the p function. This is how it looks like. Here we will check if is empty. This means if stack is empty, then print stack underflow and exit with exit failure status, right? Otherwise, simply return stack ARR 0. This is very simple function. It simply returns the topmost element of the stack. We know that the topmost element is at index 0. That's why we have to return stack ARR 0. Please note that the name of the array which is representing the stack is stack ARR. Okay? Now this is the right time to see the complete code in code blocks. You can see the complete code over here. These two are global. You can see the first variable is global and stack ARR is also global. This is isFull function. This is isEmpty function. Here in this push function, we are checking this. If is full, if stack is full, then print stack overflow, else continue. Here in this pop function, we are checking if is empty, then print stack underflow, right? Else continue. And then we have this peep function for the purpose of returning the topmost element of the stack according to the requirement. And then we have this print function to print all the elements of the stack. Obviously, the topmost element must be printed first, then the second topmost element and so on. Here in this main function, obviously the execution starts from the main function. You can see that we have two variables, choice and data. Here we have a while loop which runs infinitely. We have some set of printf functions that simply ask the user to enter the choice. Here we have all these different choices, 1, 2, 3, 4, 5. 1 indicates push, 2 indicates pop, 3 indicates print the top element, 4 indicates print all the elements of the stack, 5 indicates quit. Here we are receiving the choice from the user, and here we are simply storing that value, that choice, inside choice variable. Here I'm using the switch case, and obviously to the switch case I'm passing choice. If choice is 1, then we will ask the user to enter the element to be pushed. User will enter the element and then we will call the push function. After this break statement is required, right? If choice is 2, then we will call the pop function and we will simply store the data returned by the pop function in data variable. Finally, we will simply print that element on the screen. Deleted element is data, right? And obviously after this, break is required. There is no doubt about this, that after every case break is required. If choice is 3, then print this message, the topmost element of the stack is peak. Okay, this peak function will simply return the topmost element of the stack and will simply print this on the screen. After this, if the choice is 4, then in that case we have to print all the elements of the stack, right? So we have to call the print function. Okay. And then if choice is 5, then simply exit from the program because the user wants to quit. Choice 5 means user wants to quit. So this exit function must be called, and actually this is declared in the stdlib.h library. That's why this has to be included. Okay, I have written the comment over here for exit function. Okay. Then after this we have the default case which will simply print this message on the screen, wrong choice. Now let's execute this code. Okay. Let's enter the choice. Let's say I want to push an element. Let's say I'm interested in pushing 45. Okay, let's push one more element. Let's say this is 78. Now I just want to print all the elements of the stack. For this I have to enter 4. You can see all the elements of the stack, 78 and 45. 78 is the last inserted element. That's why it has to be printed first. And then after this 45 is printed. Now let's just try to pop an element from the stack. For this I have to enter 2. The deleted element you can see is 78. You can see this over here. Deleted element is 78. Now let's print all the elements of the stack once again. You can see there is only one element in the stack, that is 45. Let's just call the pop function once again. For this we have to enter this choice 2. This time the deleted element is 45. And if we try to pop once again, then it will simply print this message, stack underflow. Isn't that so? And process returned 1, which is an abnormal termination. This clearly states that our program is working fine. You can run this on your own. Okay friends, this is it for now. Thank you for watching this presentation.